Hello, my physics friends. I am so excited to do physics with you today. My name is Samantha Bonelli. I am the physics category specialist at Wards, and welcome to Probeware with AP Physics. So, just a reminder, if everyone could please mute your phone so that everyone can hear the presentation. You can do so by pressing *6. But of course, if you have any questions, I'd love to answer them to the best of my ability. So you can press *6 again to unmute at any time to let me have your questions. And you can also type them through the WebEx chat feature as well. So that's really nice. So our objectives today are going to be to implement technology with classic lab experiments for AP Physics. And we're going to experiment the power and convenience of our Datahub. It's a revolutionary all-in-one Probeware system. And I really wish that my school had these when I was in college, because when I was in class and doing a really complicated lab activity, I would be reaching for my force probe and, oh, I need my thermometer, and something wouldn't be charged, and I would have to charge it and go back. But this is all in one. You charge one thing, you use one thing, and more importantly, you purchase one Probeware system. So this is gold. This is my best friend. So a little bit more about the physics version of the Datahub. The built-in sensors, there's a list on the spreadsheet or on the presentation if you like, but there's air pressure, ambient temperature, an accelerometer, current, external temperature, light, a microphone, motion, a universal input. So if you have any other sensors such as vernier, you can use that in the universal input, as well as two voltages, -30 to +30 and -500 to +500. Now, there are a lot of sensors, so it's very user-friendly though. There are little pictures all around the Datahub, and the temperature has a little thermometer, and the microphone has a little microphone on it. So all you do is select it, and it's active. Very user-friendly, very nice for students who might get confused with technology sometimes. This is great.
Hey Sam, I have a question coming in. What is the ideal audience for Datahub?
Great question. The ideal audience for Datahub, we market to high school. So usually high school is when students are starting to get their feet wet with physics, so that's why it's recommended for high school. However, if your school in particular is starting physics in middle school, I like to recommend it for middle school as well, or same with college. If the students aren't necessarily familiar with physics yet, and they're in maybe their first or second year of college at a community college or something like that, I would also recommend the Datahub for that as well. So ideally for high school, but it can also go slightly into middle school or college as well. So that's a very good question. Thank you.
I have a question.
Yes?
What is the temperature range for the thermometer, or for the temperature? What are the ranges?
You know, I have that in my manual. I don't have that immediately accessible, so if you want, I can answer that at the end if that's okay.
Okay.
Awesome. Okay, so there are many ways to use the Datahub. The first is obviously data collection for your experiments. The second is measurements of the experimental conditions. So if you're doing an experiment that requires any sort of ambient temperature, you can use it for that reason as well. And my favorite, most important part is to help students visualize the data. So again, when I was in school, I'm a very visual learner, so it was hard for me to do all of these manual calculations. So usually when you give the students a bunch of manual calculations to do, they become very strong at the math aspect of this. But I always had some sort of disconnect with it. I wish I saw a larger picture. So that's where Datahub is really nice, because students can manipulate their experiment and watch the graph change on the Datahub and on their tablet or whatever they're using. And they can see what they did wrong in the graph and then turn around and manipulate their experiments again to try to improve the graph from there. So Datahub really provides that kind of bridge between doing the calculations and seeing it in real life. It gives you a much bigger picture for your lab experiments. So again, very much a cheerleader for the Datahub. So general directions for your Datahub. You're going to turn it on, and you're going to pair the hub to any device that you're using, your tablet, your computer. You can either use Bluetooth for the tablet or your cell phone even, or you can plug it into your computer. That's what I'm doing today, just with a simple USB cord. And you're going to download, it's called Ward's Datahub. That's all it's called, and it's free in the App Store. So you can download that right to your tablet or phone, or there's also a software available on our website for free as well to download for your PC. And you're going to launch that software or application and then follow the instructions to launch the application and then run your desired probe for your experiment. And place the Datahub in the test location you wish to analyze. For example, if you would like to analyze ambient temperature, just set the Datahub where you would like the temperature to be read, and the Datahub will read it for you. And begin transmitting data for your experiment and have fun. So, the first experiment I'm going to show you is exploring circular motion. Now I'm going to be showing you 4 examples of experiments today. They're all AP labs. And the first part, I'm going to be outlining just the traditional steps of the experiment, and then from there, I'm going to discuss how to implement the Datahub. So first, the exploring circular motion. It explains how centripetal force, the radius of a circle, and the mass of an object affect the object's linear speed when it travels in a circle. The students can sketch a free body diagram of an object traveling in a horizontal plane, as well as sketch a free body diagram of forces acting on a conical pendulum. And they can design an experiment to study the variables that affect the motion of a conical pendulum. And this one also has video with it, so that's really cool. And the way we implement the Datahub is we implement the Ward's external force sensor to collect data. Now, I'm doing this first because the force sensor is available for sale separately. It's not one of the 11 sensors built into the hub itself, so it's a separate entity. So, here is the force sensor. And the reason why there's a pig on your slide is that's our famous flying pig. That usually comes with the AP kits, and it will be included in your AP kit when you order it. For the sake of space in this room and the fact that it is rather spastic, it's got a nice breeze though, it's nice. I figured I would just show you with a hanging mass instead, just for the sake of space. So what we would do is we're going to turn on the force sensor, and this pairs with Bluetooth as well, so same procedure to set up your Bluetooth on the Datahub goes for the force probe as well, so you can set this up on your tablet. So just have to make sure that everything is all good with this.
Sam, would you like me to show the participants your iPad?
If you would like to, yeah, it's they can see what I'm doing, sure. So basically, there's going to be a 4-digit code on the back of your Datahub or your force sensor, and that way you can see the 4 digits. I'm going to look for those 4 digits on the device, so that's how you know what to look for. So it's 6822. I have a 6822 here. It is connected. Perfect. We're going to open our software, and there'll be a little Bluetooth icon right next to the Datahub, so that shows that it's on and ready. Now, you can select your rate. So for this, I'm going to do 100 per second for 10,000. That sounds really good. And we're just going to, if you want to just show them, I'm just going to simply run the experiment and turn the mass. So right now we're logging a graph. If you want to just switch back to that again to show them what I'm doing. So this can be done again with the flying pig so that the students can see the motion of the mass right there on the screen. So that is a very nice visual for the students to have. The next activity we're going to be doing is the classic resonance apparatus. I'm sure you have this in your classroom. Done it a million times as a student. So, just waiting for my, here we go, we're connected, perfect. So, with the resonance apparatus, again, I'm just going to walk through the traditional method first. You're going to use a tuning fork and hit that with the rubber mallet, and the students are going to raise the cup right here, and the students are going to have to listen as the water rises in the tube. The students are going to have to listen very, very closely for a change in pitch on that tuning fork. So the students are going to record at which number the water initiates that change in the tuning fork. So usually I like to connect the Datahub up here because the microphone can be on and we can make a nice graph from that. This is going to be really difficult to do myself. Usually this is a 2-student project, so I wish I had a couple more arms, but regardless, I'll show you how it's done. So, we're going to hit the rubber mallet. I'm just going to talk first because I don't want my talking to mess with the microphone and the data that's going to be collected. So, I'm going to tap the tuning fork with the rubber mallet, hold it up to the resonance tube, and then lift this cup of water. The water is going to go through this tube into the resonance tube, and we're going to listen for that really, really small change in tune from the tuning fork. I don't know if you'll be able to hear it. It's very fine, so this activity is definitely good for students to do one at a time in the classroom. You don't want to have, 5 or 6 of these set up because everyone's results are going to be different. So I'm going to show you once the procedure, and then I'm going to show you the data. I'll bring my laptop back over so that you can see the data once I'm done. So without further ado, so I don't know if you heard that. It's actually louder than usual in this room. So it was very loud. So I will show you the data that I received from the graph. So as you can see on the graph, there's kind of leveled out right here, and it started to get really quiet, and then there was a spike. So this is a nice visual to add for the students so that they can see their spike in the tuning fork when that resonance tube reached that level for the spike to happen in the tuning fork. So this is another way of the students visualizing another aspect of the experiment.
Question just came in.
Sure.
They saw an iPad and a laptop being used. What other devices, Apple, Android, can be used with the Datahub?
Absolutely great question. So as of right now, The Datahub is Apple and Android friendly as well as PC, so you can use an iPad, your iPhone. I use my phone all the time if I'm on the go doing little experiments because, you know, us physicists love to just do experiments wherever we are for no reason, right? So that's my favorite part of the Datahub too, is you can do it right on your Android phone or on your iPhone, and also the tablet for Android and the iPad as well, and your PC. It will plug right into your PC. I know a lot of people have Chromebooks now. We are starting to develop a software for Chromebook. I don't know when that's going to be done. It takes a while to develop another branch to this. So just know that that is in production right now.
What does it have the capability to do a frequency analysis of the data?
Yes. So
Excellent.
yes. So there are options on this to change. You can save an entire, I don't know, it's thousands of data points if you wanted to save your entire experiment. So this is, the software itself is a lot more complicated than what I'm going to get into today. But yes, to answer your question shortly, yes, it can.
Okay, thank you.
You're welcome. So just also on the slides, you'll have another set of sample data. I tried to put sample data with everything. This my boss actually did, so he's a lot better than this than I am. On your PowerPoint, there's a very, very flat line with 2 spikes. So he did the procedure twice with one data run. So the students will very obviously see the spikes in those 2. So I guess I was careless. I'm very sorry. This is a lot better than mine. So our next one will be simple harmonic motion. Again, just in case anyone new has come, I'm going to traditionally run through the steps of the classic experiment and then tell you how we're going to implement the Datahub after. So for the simple harmonic motion, it's experimentally determining the spring constant of a spring by measuring the period of a mass spring system. We're going to measure the restoring force of a spring and use it to determine the spring constant. Create an edited video documenting your experiment. That's always an option for the kids. The kids usually love to implement more technology. And we're going to use the words Datahub to construct graphs of the spring's motion with the motion detector. Now, the motion detector, people are usually thrown off by this because it's not a button. But that's because it's on the bottom side. I was looking for this for so long and I didn't even realize it was right on the bottom. So you flip this up, this little door, and there's the motion sensor. So, going to take this spring here and attach this mass at the bottom. Usually I have a stand with the spring mounted here and then the mass mounted here. And what you can do is, this transmits very far. You can have something moving all the way up here or even farther and it will still record. This motion detector is very, very sensitive. So usually I like to have the spring with the motion detector on the floor, but you won't be able to see that. So for the sake of you seeing what I'm doing, I'm going to hold the spring here, and we're going to just, every time we start a new experiment, we're going to open up the little Datahub icon. I'll show you again just in case you didn't see. There's a little Datahub right here on the top of the screen, and here are all of your sensors. So I'm going to turn microphone off because we're done hearing me talk. And we're going to select distance. So we are good with that. And I think turn the microphone off on that as well. And I'm going to run our experiment and just show you the mass right over the motion detector. I'm making a lot of spikes here. So the students, if you slow it down, the spikes obviously get smaller. So this really allows students to manipulate graphs and get that instant gratification. So if they really go crazy, they can see the graphs, and if it's really big waves, they can see that as well. So it's really nice. This one's really nice for instant gratification so that students can see what they're doing immediately when they're doing it. Okay, stop. And again, I included, I think there's just one example of that is the data when I have the spring up high and the motion detector on the floor, and I let the spring go, and I just let it go for a very long time. So that is the data that's on the screen right now. Okay, and then again, there are two samples of data there for you. And this is my absolute positively favorite one. Time constant of an RC circuit. Circuits were my favorite in school. I would lock myself in the lab and I would just build circuits. You understand, I'm sure. So, right here, I have a pretty simple circuit, but of course with AP Physics, we like to challenge them more and more and more. So, of course, in the booklet, there are suggestions with different circuits to build. So they go simple to very, very, very complicated. So it's up to you how you want your students to build their circuits. There are some pretty difficult ones that come in the AP booklet. So I'm going to change to voltage here. And we're just going to press, there's a little voltage button on our Datahub. I'm going to change that right to voltage. And I'm going to plug in right here. Now if you can't see, it's just a simple, there's a resistor and a capacitor, and I just have a battery right here. And what I'm going to do is the students are going to recreate this time versus voltage graph. So as you can see, the voltage rises, and usually the voltage is going to fall gradually. But what I'm going to do here for the sake of time is I'm going to short our circuit right at the top here once we reach our peak, and there's just going to be a straight line. So that's why you're going to see that my curve is going to be slightly different than this one, just for the sake of time. But I really like this because this gives the students a challenge. So they see a graph and they're challenged to recreate it with their own experiment. So, voltage is on, my circuit's all set up. Let's start. I'm going to hold the battery on the circuit for 5 seconds because that's what showed on the graph. There's a 5-second rise in voltage, and then I'm going to short it. So there's going to be that fall. 1, 2, 3, 4, 5, short. So I did pretty well right there. As you can see right here, so you can compare with the kids and see if they did well or not. And then if they didn't, they can hold the battery longer and manipulate the circuit until they've come up with the ideal accepted result. So again, I think I've also included sample data in the PowerPoint to show the curve. And that's all I have for experiments. Now, I know I had a few questions already. Does anyone have any other questions that they'd have for me?
What are these called in the catalog? Datahub?
Yes, it's called Ward's Data Hub. And there's actually, if you wanted to log on to the website, it's wardsci.com/datahub. And then there'll be a nice landing page with all of our data hubs, frequently asked questions, examples, software. So that will, there's actually on the next page of the PowerPoint, there's a list of products, and the Ward's Physics Data Hub is listed on that PowerPoint, and its item number as well. So if you just type that item number in right in our search box, you'll be able to see that.
Hey Sam, did you say that the force probe is purchased separately?
Yes, good question. So on the product information sheet, you'll see the last item listed is the external force sensor. So that again is our lovely piece right here. This is purchased separately from the data hub. So that is the last item number listed. Okay.
One more question. ISM units are both in metric and English?
Yes, you can actually change the units in the data hub. You can change the language. It's actually amazing what can be changed in this data hub. If you go right under settings, you can change the units. You can change to Spanish and French. You can do anything and everything you want.
Can other sensors be used with the data hub?
Yes, they can. So if you have some vernier sensors and you want to buy the data hub, but you already have things that you don't want to purchase again, you can use them in our external, there's a universal sensor plug-in right here, where you can just plug in any outside sensor from vernier, for example, and use that with the data hub as well. And it will transmit data just the same as all of the internal sensors. And
Okay, that's cool.
yes, I also want to make you aware of some very, very cool extra sensors that you can purchase for the data hub. Since we're all physics, I don't know if we'll necessarily need these, but if you have multiple classes you're teaching, this might be really cool, or to tell your friends. We have a heart rate sensor that can go in the data hub. We have a CO2 sensor. We have, there's something else that's really,
Acidity?
yes, there's respiration. That's what it is. Thank you for reminding me. There's a respiration sensor as well. So there are many different outside connectors for the data hub. And also to let your friends know, there are not only physics data hubs, there is a general science as well as physics. There is a biology chemistry data hub as well as an environmental science data hub. I don't have those listed on the items since we're doing a physics webinar today, but if you were to go on to wardsci.com/datahub, they will all be listed there for you, as well as any extra toys you want to buy. So, does anyone have any other questions for me? And of course, if you want a copy of the PowerPoint that I used today, you can email me. My email address is samantha_benelli@vwr.com, and that's listed in the PowerPoint right on the screen right now. And if you have any questions on existing products that you have, or if you're having any trouble, you can email our Plus Us team at sciencehelp@vwr.com as well. So there are a couple contacts right up here for you if you want the PowerPoint, or if you have any other help, need any assistance at all. We are here for you day and night. So, is there anything else I can do for anybody? All right. Well, thank you so much for coming. I had a lot of fun doing physics with you today, and definitely reach out to me if you ever need anything at all, okay? Bye, everyone.